Objects can be serialized and written to a stream. Later, this same stream can be read and reconstituted into an object that will pick up right where it left off. All the values it contains are stored as part of the serialization. You can transmit a serialized object over the network and have it deserialized on another computer. You can also serialize an object and write it to disk and use it as persistent data. Let me show you the simple process of serializing an object to a disk file. This program serializes a string object to a file. You can serialize an object to any output stream. The process is very similar to that of writing any other data type to a stream. This is the construction of the string object that's going to be serialized. And this is the file that's going to hold the serialized object. Just like any other output stream, the first thing you do is create an output stream object. Then, on top of the output stream, an object output stream object is created. An object of this class has the ability of taking an object, converting it to its serialized form, and then writing that to the stream. This whole process is accomplished in this one method call. Then the stream is appropriately closed to flush the output buffer and finish the writing of the serialized object. And that will serialize an object. There, we now have an object serialized to disk. Here you see the contents of the file. It has some formatting stuff at the beginning, and you can see that the characters of the string itself are included. Here is the program that reads the stream of data from the file and turns it back into an object inside the program. It's about the same process as you've seen before. A new file object is constructed to address the file. A new input stream object is created to read the stream of bytes from the file, and a new object input stream object is constructed on top of that. This method reads the input stream and converts what it reads into an object. The program that reads the object has to know what type of object it is and must have access to the class definition of the object so it can cast it to the correct type. All the detailed work is done inside this method, and the object is returned complete and ready to go. A new exception has to be caught here. This exception will be thrown if the local program doesn't have access to the class definition of the object. If this happens, you'll need to include it in an import statement or put a copy of the class file in the local directory. Here a text window is constructed and the string of characters from the deserialized object is put on display. When you run the program, it does this. You can see that the same string object that was stored on the disk was recovered and displayed. Just remember that the program that deserializes the object must know the type of object or objects that are coming in, and it must have access to the class definitions for them. There are a couple of things that you need to be aware of about serializing objects. First, before an object can be serialized, it must implement the serializable interface. This interface doesn't have any methods that have to be implemented. It just acts as a tag, so the system will recognize objects that are serializable. Many of the classes, such as the string class in the previous example, implement this interface. Not only that, but dozens of other interfaces in the standard API are extensions of the serializable interface, so it's a good chance that lots of your objects already implement this interface. It doesn't matter whether you implement it again when you define your class. Once an interface is implemented, adding it to the list of implemented interfaces to a class just has no effect. A serialized object is not really an object. You'll see it referred to as a graph of an object in places in the documentation. I've mentioned this before, but any variables defined in a class as being transient are simply not included in the serialization of data. When the objects are deserialized, the data item is simply set to its original default value. This is for work areas and temporary storage and such. A serialized object may contain references to other objects. Well, those objects are also serialized and stored as part of the stream. Then, when the object is deserialized, all the necessary objects are read from the stream, and they're also deserialized. A Java array is an object, and it can be serialized and read back from the data stream the same as any other object. As you know, the definition of a class in memory includes the definition of more than one class because it includes all the classes that are being extended. Reading an object from a stream is the same as running the constructors of a new object. Memory is first allocated for the object, and its memory is initialized to 0. The default constructor, the one without arguments, is invoked, and after that, the field values are restored from the stream, starting with the class closest to Java Lang object and finishing with the object's most specific class.